Okay, in this video, we're going to be doing 22 multiple choice questions from AP Calculus. The problems come from the course exam description that is freely available on the internet. I will put a link below, but let's get started with the problems. Problem number 1, we're going to take the limit as x approaches 0, 1 minus cosine squared of 2x over the quantity 2x squared. Step 1 is just try to sub in, but if you try to sub in, you're going to end up with 1 minus the cosine of 0 is 1, so you get 1 minus 1 over 0, or 0 over 0. So this is a L'Hopital's situation, so I'm going to just apply L'Hopital's rule. So in the numerator, kind of a lot of work, right? Because the derivative of 1 is 0, and then we need the derivative of negative cosine squared of 2x. So that's going to be negative, and then bring down the 2, cosine of 2x, times the derivative of cosine, which is going to be negative sine of 2x, and then times the derivative of 2x, so times 2. We also need the derivative of the bottom, so what I'm going to do is actually just kind of look at this and say this is actually 4x squared because it's easier to take the derivative of, and so this will give me 8x. So we plug in here, and again, because the sine of 0 is 0, and then obviously 0 is 0, we get 0 over 0 again. So we're going to do L'Hopital's again. So we have our limit as x approaches 0. What I'm going to do is just clean this up before I use L'Hopital's, because we have a positive 4 cosine times sine over 8x, right? So positive 4 over 8 is 1/2. I'm going to reduce those. Now, once I have it rewritten this way, I do recognize a limit here. The limit as x approaches 0 of sine of 2x over 2x. That actually is just 1, which you are allowed to know and you're supposed to know. So this will just give us 1 times the cosine of 0 is 1, so a final answer of 1. So that is one approach to this. I don't know if that's actually going to be the most common approach. I think the most common approach would actually be to take the derivatives again, right? Derivative top, derivative bottom. So I'm just going to show the work on that. When you get to this, the sine of 0 is 0, the cosine of 0 is 1. So this gives you 2 over 2, or 1, which is what you were expecting. And that will give us the answer D. Question number 2, let f be the function defined above. At what value of x, if any, is f not differentiable? All right, so we're going to need to show that this thing is continuous at -1 and 2, if it is. And then, if it is continuous, we need to show that the derivative from the left and the derivative from the right are going to be equal. So let's start with continuity, right? So we need the limit as x approaches -1 from the left. If you're approaching -1 from the left, our function is 2 over x. And then this is definitely just -2. We need the limit as x approaches -1 from the right. If you're approaching -1 from the right, the function is x squared minus 3. And if we plug in -1 there, we also get -2. We also know that this is the value of f of -1. So the function is continuous at -1. Now the question becomes, is it differentiable? Well, for differentiable, we're going to need to piecewise find the derivative of this thing. So I'm going to say f prime of x is. Just do the derivative of each branch, and then when you write your intervals, just don't include anything. So we lose the or equal to parts. But we have this. All right, so I'm going to use, I never know what notation to use for this, so I'm just going to say f prime of -1 from the left, right? So if you're approaching -1 from the left, you use -2 over x squared. Plug in, you get -2. F prime of -1 from the right. If you're approaching from the right, you use 2x, so you plug -1 in there. You also get -2. We're good at -1. All right, so now we're going to have to consider x equals 2. So if we approach 2 from the left, the function is going to be x squared minus 3. If you plug 2 in there, you get 4 minus 3, which is 1. And because of the way that the function is defined, this is f of 2. So we know the limit from the left, and we know the value of the function. We need to check the limit from the right. So the limit from the right, you're going to use 4x minus 3. If you plug 2 in there, you get 8 minus 3. You get 5. That is not continuous. And if you are not continuous, you cannot be differentiable. So we have a problem at x equals 2. And so our answer is going to be B. I don't know how you would get C as your answer choice, but whatever. Question 3, the table gives values of the differentiable functions f and g and their derivatives at select values of x. If h is the function defined by h of x equals f of x times g of x plus 2g of x, then h prime of 1 equals, I mean, looking at this now, I guess you could have factored that. That might have been a good idea. I didn't. I just dove in. I did the product rule on the first part. So it's going to be first derivative of the second plus second derivative of the first. And then we also need the derivative of 2g of x, which is going to be 2g prime. So we'll have plus 2g prime. Now what we need to do is find values and sub them in. So I'm going to color code as I go. I need f of 1 is 2, g prime of 1 is 3, g of 1 is -5, f prime of 1 is -4, and then g prime again is 3. All right, so in case I went too fast on that, which I probably did, I went through and I just kind of like color coded everything. So take a look there, and you can see the values that we got from the table. I don't know why they're giving you values at 2 in this table. They don't usually give extraneous information, but here they did. And then we just need to kind of clean this up. So 6 plus 20 plus 6, going to give us 32. So our answer is A. Question 4, if x cubed minus 2xy plus 3y squared equals 7, then what is dy dx? This is going to be implicit differentiation. So we're finding the derivative with respect to x of both sides of this thing. So I think it's actually a good idea to write down that. Now what we're going to do is we're just going to use the power rule on the first part. We're going to use the product rule on the second part. We're going to use basically the chain rule on the third part. And the derivative of a constant is 0. Let's employ this. So x cubed gives 3x squared. Now, product rule first. I like to take the negative and just lump it in with the first function when I do this. I find that I make fewer mistakes that way. I find everyone makes fewer mistakes that way, so definitely recommend it. The derivative of 3y squared is going to be 6y times the derivative of y, which is dy dx. The derivative of 7 is 0. Biggest mistake that I see people make is they forget that the derivative of a constant is 0. Now what we need to do is we just need to solve for dy dx. So I'm going to say dy dx is equal to, I'm going to take everything that doesn't have a dy dx and I'm moving it to the right-hand side. So I'm going to add 2y and subtract 3x squared. Then I'm going to look at the coefficients of dy dx, and that is 6y minus 2x. I'm going to divide both sides by 6y minus 2x. Then I look at the answer choices and I see this is not one of them. So I think to myself, what if I multiplied the top and the bottom by -1, which is essentially what you end up doing on these problems. We would get 3x squared minus 2y over 2x minus 6y. We look at the answer choices, and we pick B. Question 5, the radius of a right circular cylinder is increasing at a rate of 2 units per second. So I'm going to write down dr dt is positive 2. The height of the cylinder is decreasing at a rate of 5 units per second. So I'm going to write dh dt is -5. I didn't write units per second, but everything's in units per second here, so that's okay. Which of the following expressions gives the rate at which the volume of the cylinder is changing with respect to time in terms of the radius and the height of the cylinder? And then they give you the volume of the cylinder. So I need to find dv dt, and we are given that v is pi r squared h. So pi is a constant, and then we're just going to use the product rule on r squared times h. So we're going to get dv dt is pi the constant. We'll have first derivative of the second is dh dt plus second derivative of the first is 2r dr dt. So don't forget, you're always using the chain rule on this. So the derivative of every variable is d whatever dt. I think that's the most common mistake. Now what we're going to do is just fill in for dh dt is -5, dr dt is positive 2. So we will fill those in, which gives us pi, the quantity, -5r squared plus 4rh. You look at the answer key or the answer options, and none of them really look like that. So I'm just going to rewrite this as 4 pi rh and then -5 pi r squared. I look over at the answer choices, and I can see that the answer is C. Question 6, which of the following is equivalent to the definite integral, the integral from 2 to 6 of the square root of x dx? All right, people are afraid of these problems. I don't think they need to be. I'm going to put a link to a video I have explaining how I do them. I think it's pretty helpful. All right. First up, I look at all of these summations and I see that they are all starting at 1, which means what we're doing here is a right Riemann sum. I would say that 95% of the time on the AP exam, you're doing a right Riemann sum. So if you're going to focus on only one of them, that would be the one to do. I'm going to start with a graph of this thing. So we have this, our bounds are 2 to 6, so I put 2 to 6. I graphed what I think the square root of x looks like. So we're doing a right Riemann sum, so let's just put in some rectangles. We know that we need to calculate a delta x, so that's going to be 6 minus 2 divided by n, or 4 over n. Now this is an important step because if you now look at all the answer choices, 2 of them are using 6 over n as the delta x. So we can cross those out. And now we're just down to a and c. So what we'll find now is the evaluation point, the point that you're going to plug into the function to find the height of your rectangle. If you look at it, the first one is 2 plus delta x, right? You don't start at 2, you add delta x once, find the height. So our evaluation points, our x sub k's in this case, are going to be 2 plus 4 over n and then times k. So look at the things that we were given. Which of them has 2 plus 4 over n times k? That's going to be c. That's our answer. We don't really need to go crazy on these. I think we got it. Number 7, the figure above shows the graph of the continuous function g on the interval from 0 to 8. Let h be the function defined by h of x equals the integral from 3 to x g of t dt. That's an accumulation function. They're a pretty big deal in AP Calculus. Make sure you understand how to find the derivative of them and then how to work on them from here. So on what interval is h increasing? So that's exactly what we need to do here. We need to find the derivative. That's the second fundamental theorem of calculus. So h prime of x, we're going to take the upper bound of this thing, which is x, sub it in. So that gives us g of x times the derivative of the upper bound, so times 1. So h prime is g. We are looking at the graph of the derivative. So if we're trying to figure out where something is increasing and we have the graph of the derivative, we just need to know where that is positive. So 0 to 1 and then 3 to 7. Our answer is C. Number 8, we're just doing the integral of x over the square root of 1 minus 9x squared dx. If you look at the answer choices, I think they're trying to fool you here. They really want you to think that this is arcsine, but if this was arcsine, then 9x squared would be u squared. So u would be 3x. The derivative of that would be 3, and you wouldn't have that extra x in the numerator. So C and D are not the answer. So we're down to A and B. I'm going to do u-substitution on this thing. I'm also pretty confident the answer is not B. I'm not just going to pick A at this point, but I'm pretty sure it's the answer. So u-substitution, I'm going to let u be the thing in the radical. And then I'm going to find du is going to be negative 18x dx, which means that negative 1 over 18 du is going to be x dx. So we have to make our substitutions. So we replace x dx with negative 1 over 18 and du. Then it'll be 1 over the square root of u. And we have this. I'm going to rewrite this because I don't like to integrate that. I'm going to make it u to the negative 1/2 du plus 1 times the reciprocal. So we'll get negative 1 over 18 to u to the 1/2. From here, you could just pick the answer. I think it's definitely A. But maybe you go and you sub back in. But look at the answer choices. A is the answer. I do think they were trying to fool you by making you think this was arcsine problem. It's not an arcsine problem, but you should review arcsine because it can come up on the exam. Number 9, shown above is a slope field for which of the following differential equations. So I look at this, I think to myself, I see some places where the slope is always 0, so I'm just going to draw those in. So at y equals 2 and at y equals negative 2, now I look at the options and I see if I plug y equals 2 into A and B, I will get 0. It's not even an option for C and D, so those are out. If I plug negative 2 into A, I do not get 0. I actually get negative 1. If I plug negative 2 into B, I get 0. The answer is B. I have a bunch of videos on matching slope fields to differential equations. Highly recommend that you check those videos out if you want to get really good at this concept. Number 10, let R be the region bounded by the graph of x equals e to the y, which is kind of a weird situation. The vertical line x equals 10 and the horizontal lines y equals 1 and y equals 2. Which of the following gives the area of R? All right, let's first deal with this x equals e to the y situation. So if x is e to the y, then take the natural log of both sides and you will get y is equal to the natural log of x. So that's what I'm really going to graph. I'm going to set up some axes. There's my natural log of x. Now I also need to graph the vertical line x equals 10, and I need to graph the horizontal lines 1 and 2. So there and there. That's 1, that's 2. Now what does our region look like? It's this thing. So I think by far the best way to do this problem is to integrate with respect to y, which they kind of set up when they said x equals e to the y, in my opinion. So I'm going to say, I'm going to go from 1 to 2, and then this is what the rectangle looks like, so I have to do right, take away left. So it's going to be 10 minus that e to the y function they gave us, and then dy. Look at the answer choices. C is our answer. Number 11, the graph of the function f is shown in the figure above. The value of the limit as x approaches 1 from the right of f of x is, I thought that was a little tiny, so I rewrote it by hand there. So we need to approach positive 1 from the right. I'm just going to do that. There you go. You can see that the y value is approaching 2. That's our answer. Don't make a big deal of it if it's not a big deal problem. Number 12, the velocity of a particle moving along a straight line is given by v of t equals 1.3 t natural log of line break, quantity 0.2 t plus 0.4 for time t greater than or equal to 0. What is the acceleration of the particle at time t equals 1.2? I'm going to switch to the calculator, show you the calculator work, and then I'll come back and I will box the answer. And so we can see that the answer is negative 0.093, or C. 13, let f be a twice differentiable function. Values of f prime, the derivative of f at selected values of x are given in the table above. Which of the following statements must be true? In my experience, must be true problems, they're almost always IVT or MVT problems because there's just not enough information otherwise. So let's take a look, for example, at A. F is increasing between -1 and 5. I mean, all those values are positive, but we don't know what's going on at like -0.5 or 2.6. So it's not enough information. That's out. The graph of f is concave down for -1 to 5. I'm not even going to bother to figure it out. There's not enough information there. I mean, it does appear as if f prime is decreasing, but like, we don't know. It could, it could pop up to 50, for example, at 3. No way to know. That's out. There exists a C where C is between -1 and 5 such that f prime of C equals -3/2. This would have to be an intermediate value theorem because we have we have a table about f prime, but the table doesn't support the conclusion. Doesn't mean that it can't happen, right? Because we don't know what's happening at every value, just these selected ones, but there's not enough information, which means that the answer is definitely D. But I don't have to do the work because I've eliminated everything else. On the other hand, I think it's important for you to see the work, so what I've done is I've just written it out. So we're going with D, process of elimination, but if this was free response or whatever, this is the work that we would do. F is twice differentiable, therefore f prime is differentiable, therefore continuous. By MVT, f double prime of C equals f prime of 5 minus f prime of -1 over 5 minus -1, which equals -3/2 for some C between -1 and 5. That's the work you would do, but you don't have to do it because it's multiple choice. 14, let f be the function with derivative defined by f prime of x equals 2 plus the quantity 2x minus 8 times sine of the quantity x plus 3. How many points of inflection does the graph of f have on the interval from 0 to 9? I'm going to switch to the calculator and do this, but what I'm going to do is I'm going to graph f prime, I'm going to count the relative extrema, and then that will be my answer. Alternatively, I could graph f double prime and look for sign changes, but I think it's just easier in this case to do the relative extrema. So I will be back in a second. And so I'm just going to include this here because, we need to write on it. So these are the relative extrema. There are 4 of them. I'm going to go with that as my answer. 15. Honey is poured through a funnel at a rate of R of t equals 4e to the negative 0.35 t ounces per minute, where t is measured in minutes. How many ounces of honey are poured through the funnel from time t equals 0 to t equals 3? So we're given a rate. If you integrate a rate of change, you get the total change. So that's what we're looking for here. I'm going to switch to the calculator and just do the integral from 0 to 3 of R of t. I'll be back in a second to box an answer. And we can see from that we get D as our answer. Okay, the problems from here until the end are actually only Calc BC level problems. So if you're in Calc AB, you are done with this video. Thanks for watching. I don't know, leave a like, maybe share it with someone. If you're in Calc BC, we are going to keep on going. Number 16, the table above gives values of the differentiable function f and its derivative f prime at selected values of x. Also, the integral from 2 to 5 of f of x dx is 14. What is the value of the integral from 2 to 5 of x times f prime of x dx? This to me looks exactly like integration by parts. So I'm going to start with u has to be something I can take derivatives of, but I can take derivatives of anything. dv has to be something I can find an antiderivative of. That's always a little bit trickier. So I'm going to say dv is definitely f prime of x dx, which makes u equal to x. And then our dv is going to be f prime of x dx. Now we need to find du and v, but they're pretty straightforward. Du is just dx, and v is just going to be f of x. All right, so integration by parts. It's going to be uv minus integral of v du, so I'm going to write that down. So u times v minus the integral of v du. You can see that I've forgotten to put the bounds in because I don't think of integration by parts as a definite integral. I don't know if you just heard that siren that went off behind me. Who knows? So I'm going to put them in here. Just going to cram them in. We're going from 2 to 5, 2 to 5. All right, so for the first part, fundamental theorem, right? Just plug in 5 minus plug in 2. So when we plug in 5, we'll get 5 f of 5, and then minus 2 f of 2. We're going to have to go up to the table to get f of 5 and f of 2. Minus, if you look, the integral that we have here from 2 to 5 is given. It's just 14, so minus 14. This is how they give you enough information without, making you just do some annoying algebraic integration by parts. All right, we need to know f of 5 and f of 2. So f of 5 is 7, and then minus 2, f of 2 is 4. And so now we just have to do arithmetic. We're going to get 35 minus 22, which is 13. So we will box A. 17, the number of fish in a lake is modeled by the function f that satisfies the logistic differential equation. df dt is 0.04 f, quantity 1 minus f over 5,000, where t is the time in months and f of 0 is 2,000. What is the limit as t approaches infinity of f of t? Okay, so I have this memorized in a very specific way, and it all kind of comes down to, is there a 1? If you don't have that 1, right? So I memorized dy dx is k times y, the quantity 1 minus y over L. If that 1 is not a 1, you have to factor and make it a 1. But once it looks like this, the limit L is actually just sitting underneath whatever the function is called. So in this case, it's just sitting underneath the f. The limit is definitely 5,000. This is something you should definitely have memorized. Point of inflection will be at half of that value, so 2,500. Those are really the questions that they ask you about the logistic differential equation. Well worth knowing. 18, a curve is defined by the parametric equations x of t equals t squared plus 3 and y of t equals sine of t squared. Which of the following is an expression for the second derivative in terms of t? So I have two things that I always think about with this. The first one is, this problem is not hard, but it is harder than your gut instinct would tell you. And also, start out by finding dy dt, because whatever you find first, you're going to put in the numerator. So I'm going to find dy dt, which will just be, this is a chain rule problem, so it's going to be 2t and then cosine of t squared. Now I need to find dx dt, which is definitely just 2t. And from these, I can find dy dx. So dy dx is going to be dy dt over dx dt, which is why I suggest that you find dy dt first. because I guarantee you're just going to divide the first thing by the second thing. I see it all the time. Okay, now for the second derivative, which has this crazy notation because we're applying the d dx twice, we need to do d dt of dy dx over dx dt. Memorize that. It's great if you also understand it, but definitely memorize it because you are probably going to need to use it once, and never more than once, but probably once on the exam. All right, so we need to find the derivative of dy dx with respect to t. Again, it's a chain rule problem, so it's going to be negative 2t and then sine of t squared divided by dx dt, right? Not the derivative of that, just normal dx dt again. Simplify this and we get negative sine of t squared. And so we will box the answer A. 19, which of the following series is conditionally convergent? So conditional convergence is kind of a weird idea. The first thing that you do is you look at the absolute value of the nth term and you see if that series converges. If that converges, you say converges absolutely. If that doesn't converge, you're not done. Then you basically just apply the alternating series test and you see if the series converges the way it was given to you. If it doesn't converge when you take the absolute value, but it does converge when it alternates, then it is conditionally convergent. So that's what we're going to look for here. So for A, I'm going to look at the absolute value. So the absolute value, just drop the negative 1 to the k. We get 5 over k cubed plus 1. That definitely converges. That's a p series. Or you could limit compare it to a p series where p is 3, which is greater than 1. So that's absolutely convergent. For B, we're going to first take a look at the absolute value, right? So the absolute value it should really be 5 over k plus 1. I don't know what that 5 is doing there in all these problems. This is essentially the harmonic series. I mean, it's a little shifted, but it's harmonic, so this will diverge, and my reasoning is that it's harmonic. So this has a chance to be conditionally convergent. Now I want to look at the original series when it's alternating. So I see that we have alternating, the terms decrease in magnitude, they have a limit of 0. This converges by the alternating series test. This is our answer, so we don't actually have to look at the other choices. If we did look at the other choices, you would see that none of them converge at all because by the nth term test, they do not have a limit of 0. If you don't have a limit of 0, you do not converge no matter what. If you do have a limit of 0, you just have to do more work. It's not actually helpful in that regard. But there you go. The answer is B. Number 20, let f be the function defined by f of x equals e to the 2x. Which of the following is the Maclaurin series for f prime, the derivative of f? One option for this, and probably the better way to do it, is to say that the derivative of f is 2e to the 2x, write the series for e to the 2x, and then just multiply by 2. I'm going to do it a slightly different way. What I'm going to do is I'm first going to just write out what I know e to the u looks like. So e to the u is 1 plus u squared over 2 factorial plus ... plus u to the n over n factorial plus ... You want to memorize sine, cosine, e to the x, and 1 over 1 minus x. You have to have those memorized so that you can just write them down like this. E to the 2x is going to be this series with 2x subbed in. So I'm just going to replace every u that I see with 2x. And I get this. If you look at the answer choices, they've kind of left it like that in a couple of them. So I'm going to also leave it like that. Now what I need to do is find the derivative of both sides of what I've written. So I'm doing d dx of e to the 2x, which will be d dx of the thing that we have above. So the derivative of 1 is 0. The derivative of 2x is 2. And then I'm just going to like power rule, but I also have to chain rule. So that's the confusing thing here if you use this approach. So the first approach is just multiply that series that we have above by 2. I mean, that's the answer, right? 2 e to the 2x is the derivative of e to the 2x. So if I take the previous answer, multiply by 2, I can choose the answer right now. It is definitely D. I'm going to keep going with this. The derivative of the quantity 2x squared is 2x to the first times 2 over 2 factorial. And then I get over here. The derivative of this will be n 2x to the n minus 1, and then times 2 by the chain rule, and then over n factorial. So now the question is like, what do I do with this, right? I've already picked D, so I don't know why I'm spending so much time on this. But I'm going to rewrite this so that it starts looking a little bit more like the answer choices. So for the second term, we have a 2 and a 2 factorial, so we can cancel those. So we're left with 2, quantity 2x plus ... plus. Here, I'm going to cancel the n and the n factorial to give me 1 over n minus 1 factorial. and I will get this. Now the problem is this doesn't exactly look like choice D, but it's definitely the best choice out of all the choices because C has a 1 and B, it's like they forgot the chain rule all the way through. So D would still have to be your answer. So I'm going to pick D, although I do want to explain a little bit why. Basically what happens is 2 times the quantity 2x to the n minus 1 over n minus 1 factorial is the, I'm going to say, quote unquote, same as 2 quantity 2x to the n over n factorial. If you just re-index the thing, right, it's up to the reader to figure out where you're starting this or how to use your nth term. You could have 2 quantity 2x to the n minus 10 over n minus 10 factorial. That would also be fine. That would be super weird. Don't do that. But that's what we're doing here. So the answer is D. Number 21, the figure above shows the graph of the polar curve, r equals 2 plus 4 sine of theta. What is the area of the shaded region? Okay, so this is obviously going to be a calculator problem. What I'm going to do, I'm going to graph that curve in rectangular. I'm going to find the zeros of that curve. Those are going to be the bounds of the integral. Then what I'm going to do is I'm going to switch over to the calculator screen, and I am going to just evaluate it. So I'll be back in a minute to, I don't know, just circle an answer. All right, based on all of that, our answer is A. 22, the function f has derivatives of all orders for all real numbers. It's known that the absolute value of the fourth derivative is less than or equal to 12/5. The absolute value of the fifth derivative is less than or equal to 3/2 between 0 and 2. P4 of x is the fourth degree Taylor polynomial for f about 0, which is the center. The Taylor series for f about x equals 0, the center, converges at x equals 2. Of the following, which is the smallest value of k for which the Lagrange error bound guarantees that the absolute value of f of 2 minus p4 of 2 is less than or equal to k. So we're really just finding the error here. So the error in this particular case, or the absolute value, less than or equal to m, the mysterious value, 2 minus 0 to the fifth over 5 factorial. Now, where are these things coming from? 2 is what we're plugging in, 0 is the center, and since we're using a fourth degree polynomial, we have to let n plus 1 be 5. Basically, if you use the 10th degree polynomial, you're using 11. If you use the 53rd, you're using 54. You always just go one more than the derivatives that you've used. So we have this. Now we have to figure out what m is, right? So m is going to be the maximum on the interval from 0 to 2, which is the center to where you're plugging in, of the absolute value of the n plus first derivative, or in this case, the fifth derivative. Basically, in your error, if you have 5 factorial, this will be the fifth derivative. If you have 12 factorial, it'll be the 12th derivative. We're just told in the problem that this is 3/2, so I'm just going to plug in everything. So the absolute value of the error, less than or equal to 3/2 times 2 to the fifth over 5 factorial. And we have to kind of like simplify this a little tiny bit, but not really. This is just 3/2 times 2 to the fifth over 5 factorial. So we look at our answer choices, and we are going with A. All right, that's it. That's all the problems. I hope this was helpful, and good luck.